Okay, so we are recording, and I just want to start by saying welcome, everybody. Before we get into Jason's presentation, I just wanted to quickly introduce who Foothills Forage and Grazing Association is, and why we figured that this would be a good topic to bring to you guys. So, Foothills Forage and Grazing Association is... Sorry, there we go. We are a not-for-profit producer-driven group. We address issues, ideas, and innovations for forage and livestock producers in South Central Alberta. We're currently made up of 11 volunteer forage producers from across our region. If you kind of take a look to your right, you'll see the map, and that kind of shows you where Foothills operates in. And we help producers find profitable ways and regenerative ways to produce forages and livestock. Just a couple of housekeeping items. There'll be a question and answer period at the end of the presentation. If you would like to ask a question, there is a chat box function, so right here. You can kind of see just a little bubble up there, and you click on that. It gives you a chance to write a message. You can write it to everybody or choose individual participants to talk with. You will be muted for this entire presentation. Please leave your microphone on mute. And we are being recorded, and this will be available for viewing on Foothills' website by the end of the week. So without further ado, I would like to introduce our guest speaker for today, Jason Williams. Jason Williams is the Canadian manager of DATAMARS Canadian Inc. DATAMARS manufactures Speedrite and Patriot electric fence products. Jason has sold and serviced electric fencing products since 1998. He also teaches and trains staff in different fence building techniques on ranches and at retail stores in Western Canada. At home, he grazes cattle near Hanley, Saskatchewan, and enjoys his horse-crazy family. And I can say that Jason is very excited about electric fencing, so this should be a good presentation. Jason, without further ado, I will let you take over.
Perfect. Thank you, Sonia. Welcome, everyone. We're just going to...
I'm not going to mute you. There you go, Jason.
Perfect. Thank you very much. All right. Welcome, everybody. I'll just expand this. So yes, thank you, Sonia, for the opportunity to speak with everyone today. I think we're all getting used to these new platforms. The technology that's luckily available for us. So yes, I'm Jason Williams. I reside in Saskatchewan, but I'm often in Alberta and very happy to be involved with the Foothills Forage Group. It's a wonderful way to learn and share ideas for you folks in Alberta, and I've raved about you back home in Saskatchewan here, so we're excited to maybe expand some grazing groups in this province as well. So we're going to talk a little bit about construction of electric fence and some tips and troubleshooting. But if you would like, and this is going to be made available, but please take my phone number and or my email address down, because it's a lot of this needs to be spoken on a deeper level, and we're going to just skim across the top. I want to keep it informative and entertaining, and there's lots of pictures, and we've got some good videos and what have you. So just come along for the ride, and we'll talk about some tips for success and hopefully give you some ideas on how to get through some of those tough situations on electric fence. So as listed here, by far my favorite topic. My wife gets tired of this, but I used to take holidays just to build fence. And when you can never get away from work, sometimes it's nice to do something you don't have to think about too much. So I totally love electric fencing, grass management, grazing. I have to give a shout out to Jim Bauer. He'll be a member. He's been involved in grazing for a long time in Alberta, and has come over to Saskatchewan to do some tours in the past, but I would call him definitely a mentor in the grazing game out in Western Canada. So we just ran an ad with Jim highlighted in the Canadian Cattlemen. So that's the ad there. Thank you, Jim, for all you do. Cutting right to it, basically every fence is going to have three main components. Of course, there's the energizer. We're all familiar with that. A lot of times people will just buy a large or the largest one they can afford to make up for poor construction habits, but I'm going to give you some ideas to make whatever you have possibly work a little bit better. Second components that we've got to talk about are the wire and the posts themselves, what you use for insulators, things like that. And then the most important situation being the ground system and how it all works together. So basically, I apologize for anyone who's heard me speak before. It may sound like a broken record, but we can't stress this enough. So what is happening on the electric fence project is the charge is built up inside the energizer and it's pushed out through the, what we would call the hot terminal right here, down a wire onto the fence structure. As our cow grazes along and touches that fence, the shock actually runs through her hooves, right through her body into the soil, and is quickly pulled back to the ground rod system, back to your ground rods, okay? We cannot use just a piece of rebar here. Rebar forms an insulated layer of rust, and then this procedure doesn't happen, okay? So we need it to come back to the galvanized ground rods connected by another wire up to the negative terminal. It's pushed into the energizer again. This is what we call completing the circuit. And when that happens, then the grazing cow feels pain. And I will get questions later on in the summer when we turn into a drought situation in Western Canada. For the most part, August is a very hard month. Early September is not easy to fence or to keep animals contained because the circuit is not closed and this procedure doesn't happen, okay? So we need good ground rods, and that has a lot to do with the soil structure as well. So the grounding system, the earth system that we deal with, really there's a few different types. There's what we could build a fence called an all live fence structure. We have one called a live ground return or an earth wire return, and then we have a third one known as bipolar, and we are not going to have time to speak of bipolar tonight, but we can talk about that at a later time. So the longer your fence structure is, and the more ground it has to cover, the more ground rods you're going to need, okay? So it's doing more work. You need more ground rods to keep that power on the fence itself. We want to keep our ground rods 30 to 50 to as far away from another ground system as you can. If you have a shop or a barn with a ground rod in there, do not connect to that ground rod because we can confuse the situation, and your fencer will actually find it easier to push power backwards into that ground rod and then in and around your building than it will to keep it out on your fence, okay? We used to come into dairy barns and tie stall dairies here in Saskatchewan especially, where you would walk in there and you would hear a definite snapping inside the dairy barn because they've hooked up an electric fence system inside the barn, and really it's playing around. You can hear it on the radio, you can hear it snapping away because it's interfering with what's going on in the fence itself. It's not pushing power down the fence wire, it's backing it up into the ground rods. The rods should be at least 6 feet long. They sell big 10-foot ground rods. A lot of people will actually cut those in half, and we recommend at least a 6-foot ground rod. And you drive those into the ground, and you want to keep about 10 feet away from the last ground rod on those. And you're going to need 1 ground rod for every 2 joules of electrical output power. So our fencers are all rated in output energy. Some people, competitors, rate things in stored energy. So stored joules are always higher than the output, but we rate everything in what we can actually put down on the fence for you. Okay, so here's a picture of an all live ground system, all live fence system, basically. So if we have 2 strands of wire on the fence, power comes out of the energizer onto the fence. You can see it connected here, and it runs through both strands of wire. That works terrific this time of year. Might see some rain, so the soil might be damp. It can aid in the process to help the voltage make it back to the ground rods. And whether that cow leans over the top fence wire or butts into the bottom wire, she's going to feel a shock because of this. Her feet are in the soil, it races back here, complete the circuit, she feels pain. Just like this. So there's the shock that backs her away from the fence. If we're talking about predators, we've got wolf problems, bear, kites for various animals, feral dogs like the neighbors' dogs if you're close to acreage country or what have you. That'll back the dog off of the fence and protect your animals as well. So in August, or possibly in the winter, when the soil is not very conductive anymore, or maybe they're standing on top of a layer of snow or ice, we can't rely on the soil to carry the power back here, okay? So we can then disconnect this wire and use our bottom strand of a 2-strand fence to run the voltage back to the ground system and therein back to the energizer. That completes the circuit, okay? So dry soil or little soil conductivity, maybe winter, you're going to alternate those wires. If you have a 4-strand fence, then you would have a ground, a hot, a ground, and a hot. So you just alternate those. The key with this is she's got to contact both wires, okay? So wire spacing is vital to make this successful. She's got to touch both wires, because really, here's what happens in poor situations, or poor soil situations, is the shock is trying to leave her somehow. Some of it gets into the soil, but then a lot of it will stop. That's why I will get a phone call later in the year saying I have a lot of voltage on my wire, but my cattle still get out. So they're doing that because they don't feel the pain of the voltage shock. What we do is we rely on the second, those alternating wires, to bring that back fully and complete that circuit. It does still interact with the rods because they're nice and deep over here, but we just need to speed up that process. So on all of our websites, if you go to speedrite.com or DATAMARS Livestock or PayTradeGlobal.com, or if you go into a store and pick up our catalog, this testing the ground system is in every one of our brochures. And so what it does is it explains how you as a farmer can actually determine if you have enough ground rods for your current soil conditions and the size of the fencer that you're running. What you're going to do is turn the power off the energizer, obviously, or you'll get zapped. And then you have to get a hold of some T-posts, pieces of steel. Some people will maybe tip the bucket of the Bobcat into the soil and then tip it up into the fence wires as well. Like, you're going to try and create a fault. You're trying to drive the main brunt of the voltage back into the soil so that it doesn't continue on past the obstruction. So we want to short that fence totally out. Then you turn the Energizer back on, and then take your voltmeter and check behind the obstruction. So behind this obstruction, I want less than 2,000 volts. And with some big Energizers, it's hard to do. So you need a lot more obstruction to lower that voltage. The voltage just doesn't disappear. Just because it doesn't make it down the fence doesn't mean it goes away. It actually races down and it starts to play around in the ground rods. Okay, so then you take your voltmeter, little picture of one right here, you clip one alligator clip onto the furthest ground rod away from the voltmeter, push that little brass probe into the ground, and it's going to give you a voltage reading on the screen. That reading has to be 0.3, as in 300 volts or less, or else you're going to need more ground rods. Like I said, if this is a big giant electric fencer and there was 9,000 volts on the wire before your obstruction and now there's 2,000 volts, you're probably going to see, you might not see the full 7,000 that are left over here, but you're going to see a few thousand volts playing around the ground rods. Every rod you add will lower this number, okay? It lowers that voltage reading. But then it adds the voltage over here so that when you remove your ground rod or your obstruction, you have a terrific amount of power staying on that fence wire. So a little hint for everyone there. We need to think of the flow of electrical power similar to water inside of a water pipe. A lot of people use the same example, and that's because it makes sense. It's easy to get your minds around. And really, the more strands that we have of hot wire on a fence, the easier it becomes to carry power down the fence structure. And it's almost like using a larger water hose to move water, okay? So in the end, what we want to do is lay out our pasture systems almost like your water supply. And if you think of your whole farm like a feedlot, then on a feedlot situation, you'd have a big, huge water line running down the center of the feedlot, and then you'd have small lines running to each watering bowl, okay? So we essentially do the same thing with electric voltage, electric fence. You want a big carrying capacity on the outer edges, or maybe a tunnel system down the center of your grazing paddocks, and then you can feed that power away from that big tunnel line. So what we're going to be looking at here is with the water, like a small garden hose, no matter how big your pump is, a small hose can't move enough water. You can have the largest water pump on earth and you won't move much water through a garden hose because there's so much resistance. So this picture here is a little garden hose. If you get a big discharge hose, it's easy to move water. So you can move more water with a small pump and a large hose than you can with a large pump and a small little garden hose. It's just there's less resistance. So power, a single strand of power is like one little garden hose. And if you have a 3-strand fence, but you do this and connect all those strands at every corner and every gate, connect all your hots together, you're making a big water line, okay? A big carrying capacity. So that then becomes like a bigger discharge hose. So this picture here perfectly explains that. Very well insulated at the corners. We have connection here. We're connecting all those hot wires together. Nice big 4-strand hot wire fence. And if you're trying to power 20 quarters of land with one big humongous electric fencer, you have to leave the yard with this, if not more, so that at the far end of 16 quarters, you're going to have enough available voltage at the far end. It has to be able to carry that power away from it, the machine, to get it further down the fence. You can't just come out of your big fencer. I don't care how much you spend on an electric fencer with a single strand of wire. You're not doing it any justice. So again, when you lay this out on your perimeter, I like to use the perimeter to carry the most power, but it's not always feasible. Sometimes you got to come up through the center and then push it out to the edges. But it makes it very easy to troubleshoot. And you do have more physical fence structure if something pushes across your initial fence wire. You've still got those outer edges to protect you. So we sell, and I think Gallagher does too, we sell a product called aluminum undergate cable. So most people's underground cable is just 12.5 gauge high tensile wire with two coatings on top of it to protect it from shorting out under the ground. We sell a product that is made of aluminum, or it's coated in aluminum, and it's 6 times more conductive than typical high tensile wire. Where that becomes effective is all of a sudden one strand of this aluminum cable is essentially more powerful than a fence built like this. So you don't lose power right at your fencer. A lot of times we can't even get enough voltage away from our electric fencer because we don't use the right lead out cable. Okay, so any more than 6 joules, I highlighted this in red, we need aluminum lead out cable or aluminum underground cable to start the process, or you'll choke it off right at the fence source. Another thing in construction to think of, not everyone has a perfectly square piece of land. If this was a quarter of land, 160 acres, the distance is a ½ mile by a ½ mile. So if you try and plug a fencer in here and you route power all the way around in a big loop, at the furthest portion, you know, because it's going to pick one way to flow, it's got to go 2 whole miles, okay, to build that loop. I like people to set up their fence just like this. So I want power to run in 2 directions away from the energizer, but I want that power to stop here, and I want the power stopped here, okay, right at the fencer. And why we're doing that is because if you have an obstruction down on this side that takes away some power, this side is fully protected and is at full power. If you have that same obstruction back here in this scenario, it lessens the power on the whole structure, okay? And you can fool the power. You're essentially only pushing it half the distance. It's pushing it half the distance 2 times, but at any given point, it only has to work half as hard. So this is my home quarter right here. So the house, the barn, corrals are in here. I send power 2 directions. So this yellow, you can see up at the top, the yellow line is my power heading south, okay? But this, people that don't have a creek think the creeks are great. I am not happy most times with the creek. It's nice to have water, but it creates a lot of headache fencing wise. And I don't control the flow of the creek. Saskatchewan water controls the flow. So half the time they'll lift or lower the creek, and that totally cuts power off a lot of my structure. I have to send power to the south, and then the green line to the north. Sask Power raises the level of this creek and screws with my fencing setup, and I lose power here. I still have power on the green, okay? I still have power on that other side. So the red, I've just reseeded a bunch of this. We're not actually grazing this. This is what I'm going to build this year. I've got most of the exterior fence done. Haven't done anything in the center, so that's my summer project. But just one more example of why, if you send power to the south and west and then to the north and west, if there's trouble down here, I still have tons of power at the top because it's only working half as hard, and those two strands are not touching each other. They don't run into each other. I send the power out two directions. So brilliant meeting last week. That was absolutely fantastic. I always enjoyed Jim Garish. I had my book sitting beside me, the MIG book that I've had for years. And he spoke a lot about planning and pasture planning and some details that I can learn things every time he speaks. But after helping people for so many years, I really want them not to overwhelm themselves when they start down this road. You see a lot of people that are conventional grain farmers, or maybe they've been in cattle for a long time, but just have never worked electric fencing into their farm. So the simplest thing you can do, and the thing that will give you the less stress is just maybe all you need is one cross fence. You don't have to make 14 or 25 little paddocks, because if you're not around to manage that, some of these you can barely get a day out of it, depends on the grass. And if you're not there to do that, don't build it that way. Jim had a great point, and he's talking about grass, but I want to mention it because I'm thinking of the human side. Like, he mentioned management of time is more important than space. So we're trying to figure out carrying capacity and whatnot. You can look at that from a producer as well, the management of your own time. If you have a wedding this summer, if you have to help a family member move or build a house in another province for a week or something, if you're not going to be there to move cattle every day, don't build it so you have to move them every day. Just do it so it's manageable in your scenario, okay? Don't let some of these long-term grazers scare you out of it. It's you can improve, you can gain 7 more days grazing just by one cross fence, okay? So another thing that Garrett mentioned is 77% of grazing occurs within a quarter mile of the water source. So that's pretty impactful, right? So that it tells you that water source is tremendously overlooked, I would think, in some operations, but it's very, very vital to success. And he mentioned that too. Long-term goals should be to get down to shorter moves. He's aiming for less than 4 days. Of course, that's, think about your grass, but even the rumen stability in those animals. Anyways, it was brilliant, and I always enjoy Mr. Garish. So another little hint, don't power your cross fence from both ends. Just run it down there in one direction and then use a corner insulator and stop that power. It's going to be way easier for troubleshooting, okay? Once again, cattle work for us, don't work for them. So if you can't handle moving those fences so often, don't build too many fences. This COVID thing, I could be moving fence all the time, but we just took cattle in 2 days ago, so not quite there. I had a lot of downtime in the COVID situation because we couldn't travel. So, but it's nice to get outside again. And as you get more comfortable with the fence, then put more cross fencing in. You know, target those different areas and graze heavier where you need to, and relax where you don't. So, water development is essential to improve your grazing plan. Okay. Training of livestock when they get, sorry, my computer just froze here. Use the spring and summer, these early seasons, to get those animals trained. Don't get seeding corn right now if you're not going to electrify any fence until winter, because you're going to have a disaster, okay? So get those animals trained now. Keep power on every fence structure you have, so that if they drift into it, if they graze into it, or heck, if something even chases them into it, let them get a shock every time, and they're going to train themselves not to touch it, okay? So you can do this in the corral even before you turn those animals out. You can build a little stretch of electrified fence in a corner, or 20 feet from the watering bowl or something like that, and then throw a pail of chop behind the hot wire. Encourage them to try and push into it and get zapped a few times, because that'll save your bacon through the grazing season. So enough of me talking. We can get into some pictures here. A few little do's and don'ts. What I want on any corner, whether you build elk fence or hot wire fence or barbed wire fence, heavy duty corners with a properly sized H brace. So this, drive by this corner quite a bit. Big heavy timbers here, railroad ties basically, and you can see that they're pulling in. The direction of pull is this way, it's pulling this way, and it's pulling that whole corner in. We see that a lot in Western Canada. Poor corners, and the fence will never last as long as it should, because they're not building that corner properly. This is on the same road. This is near Kenaston, Saskatchewan. If anyone's from Kenaston, they probably know who this is. Brilliant grazing practices over here. It was raining that year. This goes back to quite a few years ago. But I just found it interesting because I know both of these ranchers, and they both spent money building fence and time building the fence, and they're grazing. But if you look here, where you have a post there and a post way down there, at about anywhere from 80 to 100 foot post spacing, and here where it's 24 foot post spacing, this one costs 3 times more money. They both keep cattle in. They both allow you to graze grass. It's the pain they feel from the wire that keeps them in. It's not how fancy or how tight you build it or how many posts you use, okay? This is not a physical structure. It's supposed to be psychological. So try and save money. Posts are very expensive. That's the big saving right there, is the post cost. Whether using T-posts or rod posts or nice heavy wood posts like this, search for an insulator that gives you a lot of distance between the post itself and where the wire comes through. The big giant energizers that are available these days will arc. They will jump if it's not, this is almost an inch. If it's not thick like that, you'll arc out and lose power at the post. Don't forget, one of the most conductive things that we have is copper. Well, they treat fence posts in Canada with copper naphthenate. So it's every time it rains or even a heavy dew morning, if you don't have an insulator and you just nail right to your post, you lose power at every post, okay? So insulators are not expensive. They've got 10, 15 or longer year warranties on them, and they will last as long as the fence post. So spend a couple cents, get them insulated. This picture here, this was a farmer that swore up and down he was not leaking power anywhere. He's got a clean fence, and after driving 6 hours to see this disaster, it's like he's just fooling himself. Okay, he's trying to run power around. It was all in this barbed wire. There's a reason for insulators. If you have an existing structure, like here on the barbed wire, so this barbed wire fence is already up, but if I wanted to electrify a component in there, there's 2 ways you can do that. I like these things. This is called a weave-in standoff, so it just weaves in top and bottom to those strands of barbed wire, and then you would feed your hot through here. You can also just buy a nail-in standoff like that. Either way is fine. So catch up to us here. Let's see if we can I'll start this video for you. Pardon my there we go. You can see how easy it is. You just use a flat-bladed screwdriver. It twists into the wire there. Go to the next strand down, and it just twists right into your fence structure. The nice thing about these is if you rent land or if you lease land and stuff goes haywire or the farmer sells it out from under you, you can go back and unwind all of these and take them home with you. So again, this is going to be trouble. All of this barbed wire had power in it on this side. Here's some nice corner insulators. Keep that clean, okay? I get asked often on this, white corner insulators, how do you tie it to the post? So what I would do, and I didn't do it here, this is me. My 8-year-old was videotaping me, so bear with my videographer. Take a fence staple and set your wire heights on the back side of the post. Then you're going to run this wire around through that staple so you can maintain your wire distances. We don't need that on. So this is called tying the tie. Around the post, back through itself, push that up to the post, put a slight bend in the wire, don't kink this wire, it's going to break. And then you just go to twisting it around itself, and then it gets to a point right here where I come underneath. And if you twist the wire in the same direction, it'll break off clean. Okay, there's no sharp edges to catch anything there. And once that's done, this is how you attach the insulator. And I'll explain why we do this. So here on breaking the wire, I did not use any tool to do that, okay? I kinked it. If you kink the wire and spread it out again, it'll break. That's high tensile tree island wire. Then I'll fit the insulator on the wire, slide it up toward the post, and you can slide it as close or as far away as you want. That's personal preference. Now my youngster, he missed some of this, but we're just twisting the wire around itself here. And why I do that is because if something flushes through the fence, this little knot undoes itself because it's just twisted. And then it will undo itself and we don't break a wire. It might go off spilling into the grass, but it's not going to break. Anyhow, I can send those videos to anyone who wants them. You come to a fence clinic, we'll do those in person. Here we've just got the wire wrapped around. So this is the aluminum undergate cable, and this is some other black contraption. I don't know what he was doing here, but huge arcing issues. Dry grass, like this is not best practice. So anyways, nice picture of a brace post. Here we can see the line for the soil, and we've got about 5 feet, 4.5 feet of exposed post out of the ground. So this is vital right here. This is the brace post. It's a 10-foot width because twice the height out of the ground is the length of your brace post. Most farmers in Western Canada take a sharpened 6-foot post, cut the sharpened end off it, lay it on the ground, and start trying to pound this brace post here. And what that will do is over time and sometimes only a few months, it starts to lean over and pull that corner right out of the ground. So here's what they should be looking at for your brace post width. Like that thing is 10 or 12 feet wide. Okay, so nice corners right there. Tighteners, this shows all the components. Starting to build more floating braces. This is straight post here, and you would notch slightly into the post at the bottom end of your brace. Just put a plate. Some people just use an old flat stone. And then along the ground, you loop a wire on the end and back around the bottom of the post. Tighten it up as tight as you can get it so that this post never slides down, just like that. I built mine out of wood, as here. There's a wire along the ground. That corner won't pull out. It's very fast and very easy to build. Spacing, we get a lot of questions about wire spacing. What it comes down to is no matter what you're keeping in or out, the distance is basically determined by the distance from their nose to their eyeballs. Okay, so we have some guidelines that you can start with, but it really comes down to your own animals. Here's 3 good pictures. So here's some first calf heifers we grazed last year. Nose to eyeballs. An old mama cow might have a longer face. Horses are longer yet. Feral hogs in Saskatchewan now. This was shot about 500 yards from my house. Nose to eyeball. That's the distance that you set your wires at. You try to keep bears out, same thing, nose to eyeballs. This ensures, because they always lead with their heads, right? As they're grazing along, they'll contact it, and if you need them to touch a hot wire and a ground wire, they touch both wires. Temporary fence, again, I would have the outside really hot, carrying a lot of power for us, and then inside we can build permanent cross fencing, or you can use temporary cross fencing. That's either way is fine. So you could use step-in plastic posts like here, pigtail posts. It's portable, it's easy to put up, it's fast, it's usually less money than a permanent structure. So it works good for short distances. You can do multiple wires when you use these multiple tread-in posts like that, so you can set your different wire spacings very easily, and it works in the fall and winter if we're grazing corn or swath grazing crops like that. So a couple things on permanent fence. So run this around, obviously the outside, and build them to last 30 years or more. Okay, so as long as those posts will last, the rest of the structure can last that long. You put as many or as few wires on it as you like. Nice heavy corners like we discussed, and you can use T-post or rods or wooden post, whatever is easiest for you to get a hold of. So why we like insulators: they keep all the voltage on the wire. They protect against leakage back and forth from posts or different trees and things like that might come down, push your wire into your steel post. They allow some flex. This stuff is supposed to flex. It's not supposed to be fiddle string tight. And again, the nose to eye spacing, very, very vital. That's what's going to keep animals in or out. So right here, tons of distance. That's a pin lock insulator that you can nail on a wood post as well. For connecting wires, now this is to transfer power from one wire to another. This does not prevent the wires from pulling apart. This is just for transferring power. Where this is better than a wrapped around or a loop, if you don't wrap it tight enough or over time, it'll actually loosen up. The pulse only runs down the wire every 1.5 to 3 seconds. So if it's really windy out, like it's been in Saskatchewan for a week now, you can separate those wires just as the fence moves. And the last thing you want to do is an animal be touching into the fence and there's no power conducted to back it off the fence and keep it in the structure for you. Okay, so this is a knot that, again, I teach a lot of people how to tie this knot. It's very clean. There's no sharp edges. Okay, I don't have a video on the knot. I'll put that on Instagram or something. I can maybe share it to the Foothills Forage site, but I am going to get the boys to video me tying this knot because everyone wants to see how it's made. Product that we can provide instead of tying a knot like that. I like to tie the knots because it's less money. These are fast and easy, and again, they don't have any sharp edges. I don't want anyone to ever get caught on a fence structure, animals or humans. And so we need to make sure there's no sharp ends hanging up anywhere. So this is called a wire link. We feed the power in from both ends. Very simple that way. So again, you just push the wire in there, and it's sort of like one of those kids' finger traps that you stick your fingers in those cardboard deals and you can't pull them out again. So called a wire link. Some people use crimps, that's fine. Be sure when you put the crimp in the crimper that they're not laying sideways. They're meant to be crushed from the top and the bottom, like that. There's the crimping tool. Fits a variety of sizes of crimps, like that. So here. Tighteners, my favorite tightener, these inline, they're meant to go in the center of your stretch. So if you have a 1/4 mile of wire, you put this at the 1/8 mile area and fit 10 feet of wire on that bobbin. So you can tighten a pile of fence. But be known, this is not supposed to be fiddle string tight, okay? So this strainer, again, it's for the high tensile wire. I'll get rid of the sound so I can talk over this. You lay the wire in the groove here, and then we have a tightening tool that fits in the backside and just commence to twisting. And then there's a keeper or a key that actually slides into those holes and creates a binding effect, and it prevents that from loosening off. So there's the backside, fits up under the wire. Then you'd slide the tool in here. It's a 1/2 inch. You could use a 1/2 inch drive ratchet if you want, but you'll get kicked in the teeth with it once in a while. The edge of the tool binds on the wire, so it safely holds it in place for you. Then you can just drop the key down in the top, fit it through both layers of holes. So there's holes here and holes at the bottom, and then it's in your structure. Safe and effective. Here's another use. Our units actually have a hole in the bobbin so that you can use it as a repair tool. So if you have a broken wire and you're not comfortable tying a knot, or you don't have your crimps, you can actually feed wire in through that bobbin from each direction through the center of it, and then tighten as per normal. And it does 2 things. It repairs the wire, and then it gives you some tension on the wire itself. So beware of imitators, because the imitators do not have that hole through the center. Only the true test units do. will just show the so you can see now this is in the ground. It's hard to do with this wire was just randomly in the tall grass here, but I wrapped it up anyways. You got to fight with it a little bit, but you understand the concept. Just see it come in from both sides. Again, the tool will go on once more. And as you tighten up, it binds and starts to grab and tighten that wire for you. So it's actually easiest to walk backwards once you start the wire until it's tight, and then as you crank, you walk in towards the fence structure itself. This is how loose we need to keep the wire. Again, you have to put your pride aside. This is not fiddle string tight barbed wire show fence to keep your neighbors jealous. This is to keep cattle in, okay? Don't phone me in the fall because you're mad that the elk went through your fence and the strands broke. If you do this procedure, you walk in the center of your posts. So these posts are 80 feet apart. So at the 40-foot mark, I can push the top strand of wire all the way to the grass, all the way to the ground. And if it's not able to do that, your fence is too tight. There's quite a distance between the posts, top strand, all the way to the ground. That's your tightness, okay? We're relying on the psychological effect of the fence hurting us to keep them in. We don't need more posts. And again, here's a video, very interesting, but it's going to show a lot of elk flush through here, like 40 or 50 of them are going to go through a tall bison fence, and the fence flexes and the fence allows the elk to pass through. We're never going to slow the elk down. They're going up this mountain ridge in the background. So we're going to allow them to go through. They're going to beat up that wire. They're going to beat up there's fiberglass fence posts that are banging around. But the neat thing about it is in the foreground, this is a grazing project for bison, and they don't want the bison up on that ridge. They'll let the elk go on the ridge, but not the buffalo. So I'll just press that. So again, we can see them flexing those posts, but the wire is not breaking and the post isn't breaking. You're not going to slow these elk down. I don't care how many strands you build. They're going through. So it's very safe. And there's an elk at the end that takes a heck of a tumble, but she gets up and runs away with the rest of them, okay? So this one there, so she fell on her nose. She's shamed, but she catches up with her friends, okay? So that's vital, and we didn't lose any bison out of there, just the elk. So just a few minutes left. Really quickly on our voltmeter tool, we sell a little unit for 20 bucks that has 5 lights on it. That is not enough to tell us what's really going on in the fence. So please spend another $20 and get one that is a digital voltmeter, okay? We need 2,500 volts at the far end of our pasture to keep cattle in. We need way more than that just for these small ruminants, okay? So it has a probe on it. If the soil conditions are good, just press the probe into the soil. But no creature on earth has a foot that looks like a brass probe. So if it's getting dry, just lay the probe flat on the ground and gently step on it, and then clip onto the wire with the alligator clip, and that gives you more proper representation of the power that's on the fence itself. Real quick, some pictures of different gate products. Here's a spring gate. That's electrified. The handle is not. Again, This handle is not electrified. The tape is. We sell a product called a cutout switch, and a cutout switch acts like a light switch. Power comes in here, travels along the knife into the other terminal and out the top. If you want to stop power, we open the switch. Makes troubleshooting very easy. So we can protect our property and we can protect our animals from various things. It deters predators and it allows us to maintain grazing, okay, and contain those animals. We have to train them early, and I really want voltage on every piece of fence that they have. So it's just another tool for your business. I covered these points. I know we're running out of time. Sorry, I went a little long, Sonia, but anyone, here's my information. Call anytime, and I hope we have a little bit of time for a question or two. If not, I'll definitely email them and answer those questions at a later date.
Excellent. Thanks, Jason. This is a good time for you guys to pop any questions if you have them in the chat function. We'll give it a few minutes and see if anything comes in, Jason. In the meantime, please feel free to take down Jason's phone number and contact information. I will be sending out a post-webinar questionnaire, or just a quick five question survey, and I'll make sure Jason's information is also included in that if anybody needs it.
That's perfect.
And thank you for the presentation, Jason. It was excellent.
Oh, no problem. I could talk all day on a lot of those topics singularly. So, but we do a lot of predator fence construction, and I didn't even get into a lot of the predation side. But if there's people with sheep, goats, or up in northern Saskatchewan, Alberta, in the forest fringe, that we're dealing with some big wolf issues, and these feral hogs in Saskatchewan is a big deal. So we can fence for anything. So please just let me know.
Okay, we have a question here, Jason. What is your opinion on sleeve insulators, both on corner posts and for inline posts?
Was that sleeve insulators?
Yes.
Okay. We manufacture sleeve insulators. If it's a small energizer on just a short piece of ground, small pasture, sure, you can use that. But understand the thickest wall in the sleeve insulator is about 1/8 of an inch thick. So most all of my energizers will throw power right through that, okay? So you're gonna leak power through those if you put too big of an energizer on there. But it's a product, it certainly works. It's better than a old tire tube. Some people used to wrap tire tubes around posts and think they were insulating. Rubber tire tubes are made of hardly any rubber, but it's mainly, oh shoot, I forget what they're made of. It's not actually black gum rubber anymore, but they're actually conductive. So you leak a lot of power. So I would rather a sleeve type insulator is better than nothing, but always best just to tie off a heavy corner insulator, the polyglass filled corners like I showed in the video there.
Excellent. Thanks, Jason. I haven't received any more questions yet, but Judy does say thank you. Lots of good information.
Wonderful. Well, thanks so much for having me. Again, I can make those videos shareable to the association, or I can send them privately if anyone wants to get a hold of me.
Okay, excellent. That sounds good. For everybody who tuned in today on the webinar, thank you so much for taking the time to join us today. Both DATAMARS and Foothills Forage and Grazing Association appreciate it. And if you guys have any questions, then feel free to connect with Jason or myself, and you'll have my contact information when I send out the emails tomorrow. So thanks, everybody.
That's wonderful. Thanks, Sonia.
Awesome. Cheers. Thanks, Jason.
Yeah. Bye now.